Section 4.2 Interactive Assignment Objective 3. Here we want to be able to consider the data set given in the accompanying table, and we're going to complete parts A through D. In part A, we want to be able to determine the least squares regression line, and then we're going to choose the correct answer below. So I'm going to go ahead and select the icon so I'm able to open this up in the StatCrunch. Okay, so now if you notice here that the first column represents the X column, the second column is the Y column. And so what I want to do is I'm going to go to Stat, and then I'm going to go here to where it says Regression, and then I'm going to select Simple Linear. I'm going to make sure that the X variable states that it's the X, the Y variable is Y, okay? And then at this point, there's nothing else for us to choose, so we're just going to go ahead now and select Compute. Okay, so what I'm going to do is I'm going to copy this data into our screen here so we can go over this information that's given. Okay, so if you take a look here, okay, recall that we want to be able to find the linear regression line. So if we have an equation where y is equal to mx plus b. M represents the slope, and B represents the y-intercept. Okay, from our given information, we can see what is given here. Well, the slope is 1.8. So we're going to be able to determine what that slope is, and we can see that the intercept, or the y-intercept, is 1.4. So let's go ahead and then write that equation here. We're going to have y, which is equal to the slope, which is 1.x, plus the y-intercept, which is 1.4. Now, I also want you to see here that it also gives you the equation here. It's just written in a different form. You have the y-intercept written first, and then the slope 1.8x. Okay, so this is our linear regression line. So let's go back to our question and answer part A. It says determine the least squares regression line, and if you notice, it is part D, where it says y is equal to 1.8x plus 1.4. Okay, now the next question is they want us to graph the least squares regression line on a scatter diagram. So I'm going to open this information back up. Okay, so what I'm going to do is I'm going to select Options, okay, and I'm going to select Edit. And so we already have our X variable and our Y variable here, okay, and then what I'm going to do is I'm going to scroll down a little bit, okay, and then when I get to the following, it's going to say Fitted Line Plot, so we're just going to make sure that that's highlighted, okay, and then what I want to do is I'm going to come down here and I want to select horizontal lines and vertical lines just so I can see the graph a little bit clearly. And then I'm going to select Compute. Okay, so it's going to give me the same information that I got. Now, if I move to this next page, what it's going to do is it's going to give me the graph. So I'm going to go ahead and copy this graph. Okay, and then we're going to go over this graph a little bit here. Okay, so when we take a look at this graph, there's some information that I want us to pay attention to. So let's first determine the horizontal axis. Okay, so what I'm going to do is I'm going to find out where the X and Y axis is located here. So we know where our X and Y axis is, but I want to show you. Here is our 0. That's where the 0 is located. Okay, and then this graph here is also where 0 is located. So that means that at this point here, this represents the origin of 0, 0. Okay, and then if I look at this point over here, down over here, that means if I go over to the left, -1, -2, and then I'm going to go down -2. That means that this point represents -2, -2. Okay. Now again, I'm going to start here. I'm going to go over to the left -1 and then down -1. And so therefore that point represents -1, -1. Okay, this next point over here, if this is 0 and then we're going to go up 2, so therefore this point is going to represent 0 and then +2. If we take a look at this point here, if we move to the right 1 unit and then up 3, that means that that point represents 1, 3. And then this last point up here, if we move to the right 1, 2 units, and then that's up 5, therefore this point represents 2 and then 5. Okay, let's verify our data set. So this is our data set. Here's -2, -2, -1, -1, 0, 2, 1, 3, and then 2 and 5. So there is our scatter diagram with our points. Okay, now what we want to be able to do is we want to be able to match this graph with the choices it's given in this question here. So in order to do that, we need to look at each graph and then look at the points to make sure that they verify. If you look at part B, okay, when we open that up, it's going to match all the points that we have. We go to the left -2 and then down -2. We go to the left -1 and then down -1. Here we start at 0 and then we go up 2. And again here we're going to go over 1 and then up 3. And then here we're going to go over 2 and then up 5. So you want to check and make sure each one of these graphs match those particular points. In this example, B is our choice. Okay, now what we want to do is, it says that the equation of the line that contains these 2 points. So if we wanted to find the line that contains these 2 points, this is the line that they're using. We want to be able to compute the sum of the squared residuals of the given data set for this line. So what I'm going to do is I'm going to come back in here, okay, and what I'm going to do is I'm going to create a scatter plot. So I come down here, select scatter plot, okay, and then what I want to do is I'm going to select the x variable again as x, and then I'm going to select the y variable as y. Now what I want to do now at this point is I'm going to come all the way down to here where it says overlay polynomial order, which means I want to plug in the equation that they're asking for part C. And so down here I'm going to select 1 because it's a degree of 1. Okay, now what I'm going to do is I'm going to go ahead and then take a look at my question. Okay, and that question has this line here, which is y, which is equal to 1.75x plus 1.5. And so what I want to do is I want to select this second option. Okay, and when we look at this, this is our equation, how we want to put this in here. Well, this C0 represents the y-intercept, and the y-intercept is 1.5. So we're going to go ahead and put in 1.5. Okay, and then we have our slope, and our slope represents 1.75. So I'm going to go ahead and put that in there, 1.75. Okay, now what I want to do is I want to scroll down just a little bit further before I do this graph. We want to make sure that we display the points. Okay, and then we want to select both the horizontal and vertical lines so we can create a grid with our graph. So I'm going to go ahead and select compute. So there is my graph. I'm going to go ahead and copy that on my page. Okay, so now let's analyze this graph just a little bit so we can answer those questions. Okay, so here's my graph. And what I want to do is I'm just going to go ahead and I'm just going to kind of carry over this 0 axis. So this is our 0 line. Okay, and then here is our y located at the origin. So right here, this point represents our origin of 0, 0. Okay, now if you notice here, we can see that our first point again is at -2, -2. Okay, we can see that our next point here represents our -1 and then -1. And then this point is going to represent again 0 and then 2. and then this point represents 1 and then 3, and then this point represents 2 and then 5. Okay, and then I also want to make note that this represents our equation, and that equation that we just graphed, this one in red, okay, represents the equation that we just put in, which is y, which is equal to 1.75x plus 1.5. Okay, and so what we want to do now is, in the question, they want us to find the sum of the squared residuals. So we need to find the residuals first, and then we're going to square it. Now the residuals is the distance from our points to the line. Okay, and so what I mean by that is, if we take a look at this first point, -2, -2, it is right on the line. So let's go back here, and I'm going to show you this table. Here is my equation. I have y, which is equal to 1.75x plus 1.5. And then here are our x values and our y values. So the first thing that we're going to do is we're going to substitute each x value, okay, which is here, in for x into this equation. So let's go ahead and do that first. So we're going to take, it's y hat, which is equal to 1.75, and then we're going to multiply it by that x, which is -2, and then we're going to add 1.5. Okay, so let's go ahead and do that. So on our calculator, we're going to take 1.75, we're going to multiply that by -2, and then we're going to add 1.5. Okay, and that gives us -2. Okay, so that gives us the value of -2. All right, now what we're going to do is we want to be able to now determine what is the residual. And the residual is taking the y value, and we're going to subtract this value that we just got for -2. So let me go ahead and highlight this. So here is our y value. Okay, and then what we're going to do is we're going to subtract this value that we just got for our problem. So now let's go ahead and do that. So we're going to take -2, which is our y value, and then subtract the -2. Well, this becomes -2 plus 2, which is equal to 0. Okay, so this 0, what does this 0 represent? The 0 represents the residual. Well, what is the residual? Well, let's come back down here. Okay, I want you to notice something here. Okay, the residual is the distance from the point on that line. Well, it's right on the line. So the residual here is 0 because the distance from this point is just going to be 0. So therefore, we're going to take this value of 0, okay, and then we're going to square it because that's what it tells us to do here. Take the residual and square it, and that gives us 0. Okay, now let's do another one here. Okay, so what we're going to do is now we're going to take a look at this other order pair, which is -1, -1. So here is where -1, -1 is located, and you can see that this point is below the line. So there's a reason that we need to determine why this is below the line. So let's come back up here. We're going to go ahead and then do the same thing. We're going to take y hat, and that's 1.75. We're going to substitute the x value to be -1, and then add 1.5. So let's go ahead and do that. So we're going to take 1.75. We're going to multiply that by -1, and then we're going to add the 1.5. Okay, and then that gives us -0.25. So here's -0.25. Okay, and so remember here that we're going to take this value, okay, and we're going to subtract it from our y coordinate. So the y coordinate here is -1, and then we're going to subtract this -0.25. Okay, well that makes this a plus, and that makes this a plus. And that -1 plus 0.25 becomes negative 0.75. Okay, now again, this represents the residual. Okay, so this is our residual. So now, what does this negative 0.75 represent? Well, I want you to take a look at this line here. Okay, and this line, the distance from this line to this point is the residual. And if you notice that it's below the line, and the distance from that point to that line is the residual. The residual is taking the following. It's taking this value. So we have negative 1 minus 0.25. So this negative 1 minus this minus 0.25 gave us negative 0.75. And that is the distance from this point to this point, which means that this point is below the line. Okay? Now we're going to look at the next point, which is 0, 2. And if you notice that this 0, 2 is above this line. So let's go ahead and do the same thing here. Now before we do that, we definitely got to make sure that we do the square. So over here, we're going to take negative 0.75, and then we're going to square that to give us our value. So we're going to take this negative 0.75, and then we're going to square that, and that gives us 0.5625. So 0.5625. Okay, now we're going to look at the next value for x. So we're going to take y hat, and that's going to equal 1.75. We're going to multiply it by the x value, which is 0, and then we're going to add the 1.5. Well, anything times 0 is going to give us 0, so we get 1.5 as our value for y hat. Okay, and then what we're going to do is we're going to take our y coordinate, which is 2, and then we're going to subtract our 1.5. Well, if we take 2 and subtract 1.5, we're going to get positive 0.5. Okay, and again, what this represents is the residual. Now, this is a positive 1.5, which means this point should be above that line. And if you notice that that is the distance from that line to this point. So that represents the residual of 0.5. So now what we're going to do is we're going to take this 0.5 and then square it. So we got 0.5, and then we're going to square that value. And 0.5 squared is 0.25. Okay, now let's go ahead and do the next 2 points. We got 1, 3, and then 2, 5. Now again, if you take a look here, here's the point 1, 3. So noticing that this point is below the line, the residual should be negative. Okay, so we know it's going to be negative because it's below the line, but let's go ahead and then calculate our points. So we're going to take y hat. Again, we're using the equation 1.75. We're going to multiply that by 1 and then add 1.5. Okay, and so calculating this result gives us 3.25. And again, just so we can highlight it, we know that that represents y hat. And so what we're going to do, in order to find the residual, we're going to take the y value of 3, and then we're going to subtract 3.25. When we subtract that, we get negative 0.25. And as we stated, we should be able to get a residual that is negative. So again, if we take a look at our residual, down here, this residual represents the distance of negative 0.25. Okay, and then what are we going to do? We're going to take this negative 0.25 and then we're going to square it. And that's going to give us positive 0.0625. Okay, now if we take a look at our last point, this point is right on the line. So that means the residual should be 0 if it's on a line. But let's go ahead and calculate this. So we're going to take y hat, That's going to equal 1.75, and we're going to multiply that by 2 since that's x, and then add 1.5. So 1.75 times 2 plus 1.5 is going to give us 5. And so therefore, there is our value for y hat. Okay, now we're going to take the y value of 5, and then we're going to subtract 5, and that's going to give us 0, which gives us a residual of 0. And then 0 squared is going to give us 0. Okay, so now we found the residual squared for each item. Now what we're going to do is we're going to add these up in order to answer this question here, which is the sum of the squared residuals. So let's go ahead and do that on our calculator. So we're going to take the value of 0, which is the first one, plus 0.5625 plus 0.25, and then plus 0.0625. And that gives us 0.8750. So 0.8750. Now we're going to go ahead and put that into our answer. So it says here, we're going to put that in here, 0.8750. Checking our answer gives us that result. Okay. Now what we want to do is it says compute the sum of the squared residuals of the given data for the least squares regression line that was found in part A. So let's go ahead and do that. Okay, now if you remember, okay, here's our graph from part A. You can see that, and I'm going to copy this point here. So let me go ahead and copy this graph so we have all our information in here. Okay, so if you notice here that this point is above the line, this point is below the line, this point is above the line, this point is below, and this is right on there. So you can see what's going on with the residuals. So I'm going to do the first one, and then I'll fill in the rest. So remember here that what we're doing is we're taking the value for x, right? And the value of x is -2, and we're going to plug it into this equation. So we're going to take our y hat, and then that's going to equal 1.8 times -2, and then plus 1.4. Okay, so if we do that again on our calculator, we're going to take the following. We got 1.8 times -2, and then plus 1.4. And again, there's -2.2. So there is -2.2. Okay, and then what we're going to do is we're going to take the y value, and then we're going to subtract the y hat value. So we have -2, and then we're going to subtract -2.2, which becomes a plus. So -2 plus 2.2 is going to be positive 0.2. Okay, now again, that represents the residual. Okay, so the residual again is the distance from that point to the line. So let's take a look at that. So down here we can see that the distance from here to here, so the residual is positive 0.2. And then over here, we're going to take that value of 0.2 and then square it. And then that's going to give us the following value, 0.04. And now I'm going to go ahead and fill in the rest. Okay, so now let's go ahead and take a look at filling this in. We take the value of x, we plug that in. And then to get this value, and then we're going to take our y value, which is -1. And then we're going to subtract the y hat to get the residual of -0.6. And if you notice, our next point is now below -0.6. So let me go ahead and put that in there. So the distance is -0.6. Okay, and then again we have put 0 in here, we get 1.4. The y value of 2 minus 1.4 gives us 0.6. So that means that the residual here, or the distance, is positive 0.6. And then for the 0.13, we put the value of 1, we get 3.2. 3 minus 3.2 is negative 0.2. And if you notice here, the distance from here to here is negative 0.2. And then plugging in the value of 2 gives us 5. 5 minus 5 is 0, so it's right on the line. Okay, and then what we're going to do is we're going to take each residual that we have, and then we're going to square that value. Okay, so we get 0.04, 0.36, 0.36, 0.04, and 0. And when we add up all those values, we get 0.80. So let's go ahead and put that answer in here. So the sum of the squared residuals is 0.80. And then let's check our answer. Okay. All right, so there's our result. And that concludes this question.